So welcome to the Mining and Metallurgical Society of America webinar series. MMSA is an association of mineral resource professionals whose members represent all facets of mining and metallurgical interests, both domestic and internationally. MMSA has always been a cohesive group of senior people from the mineral industry. The society is dedicated to increasing public awareness and understanding about mining and why mined materials are essential to modern society and human well-being. The Society concerns itself with fundamental principles with problems facing the industry in areas such as legislation, economics, education, as well as environmental concerns, labor relations, and health and safety. Representatives of the Society from time to time testify before legislative bodies and provide advice to federal agencies. I'm Kristen Guerin-Davy, MMSA member and the new social media and webinar director. I'll be introducing our webinar today. The title of today's webinar is Mine Closure and Associated Costs, Impact of Closure and Key Points to Consider. Our speaker today is Jeff Parsley, and he is with SRK Consulting. If you would please enter questions into the chat, we'll read those out and the speaker will answer the questions after the presentation is completed. I'll turn it over to Curtis.
Good afternoon, everyone. My name is Curtis Clark, and I'm chair of the committee for putting on webinars for qualified persons and for guests of MMSA. Jeff, as Kristen mentioned, is a corporate consultant with SRK Consulting out of Reno, Nevada. He's been in the industry for 40 years, and he has worked on mine closure projects for the last 35 years, developing a number of cost estimating models. He was a principal author of this public domain software standardized reclamation cost estimator, which is in use in over 30 countries since its release in 2006. Jeff, I'll put myself on mute here.
Thanks, Curtis. Sounds like you're in an airport. Hello, everyone. As Curtis said, my name is Jeff Parsley, and I've been asked to address issues of mine closure and associated costs. And as he mentioned, this is part of the program to provide opportunities for further learning for QPs. So I will try and weave that in through the discussion of a brief discussion of what mine closure is all about, how that affects us as QPs, and also we'll dive into a discussion about closure costs and some of the challenges we run into in that process. As I warned Kristen and Betty and Curtis, there's a lot of information here, and I'm going to be going fast. So those of you not familiar with the subject, it might feel like you're drinking from the fire hose, but here we go. There's me. I'm not going to leave this up long enough for you to add up all those years, but suffice it to say, I've been doing this for a long time, and I've been doing closure work for more than 34 years, closer to 35. So let's start out for a minute, just briefly. What is mine closure? Most of us know about this by now, but there's a couple of things to keep in mind when we're looking at closure, when we're thinking about disclosures on closure, when we're looking at costs. I mean, we have to recognize a few things. Mining changes the land. It also changes the way people interact with that, social, cultural, and economic context. We have to recognize that some impacts can never truly be mitigated to back to the way things were before. And that includes things like the wealth that's generated for people during operations. So when we're looking at closure, we're looking at transitioning from an economic situation into that is related to closure versus a post-closure context. One of the things that we've learned over the last 3 decades is that it's very important to look at both the physical and socioeconomic impacts and start looking at those very early on, preferably before you even get started putting in a mine. Now, obviously, there's places in the world where that's required as part of permitting. So why do we actually close mines? Well, we close mines to reduce liabilities. That's basically the fundamental reason we do it. We're trying to reduce risks, reputational risks, financial risks, risk to the environment. And we do have an opportunity because, as we all know, mining does provide positive benefits to the world and to local communities. And if we do closure well, we can leave a positive legacy overall. We also have to recognize in many places around the world, it's the law. But more than anything, over the last 20 or 30 years, it's become recognized. Could everybody please mute yourself if you're not speaking? And more than anything, we've realized that it's just plain the right thing to do. And that's really become part of corporate culture in the mining industry. Now, if you look at there's lots of definitions of what a mine closure plan is, and this is the one coming out of the IFC Environmental Health and Safety Guidelines. A couple of key things that I want to point out here. It talks about both physical and socioeconomic considerations. It's part of the mine life cycle. And after use should be beneficial and sustainable. We'll talk a little bit about all those things as we go. So one of the things we do is one of the first things we do is look at a strategy for closure. And there have been some good documents recently, good guidance documents. ICMM had the toolbox that they turned out the new version in early 2019. That's a great one. And it really talks about thinking ahead, looking at the end and starting from that point and actually coming up with a vision for the site after closure. And that includes things like repurposing things, post-closure land uses, future uses of the land, understanding what your closure objectives are, and then defining your closure actions. And an important part of this is the socioeconomic transitioning, which we'll look at. The other thing that is often maybe not overlooked, but not looked at carefully enough in many instances, and not even required in some jurisdictions, is what does the post-closure management of the site look like? So we've been doing, as an industry, we've been serious about closure for the last 3+ decades, and we've learned a few things. One of them is we've learned that it is definitely part of the mine life cycle that needs to be considered along with everything else. And that means you need to start early on in the life cycle thinking about it. Probably one of the most important things is each site is different. That means each closure plan is going to be different. You cannot cut and paste a closure plan for one site and assume it's going to work fine for the next one. We also have probably in the last 10, 20 years, we've become more aware of the importance of people in the equation. There have certainly been a number of instances where there were unplanned closures. Those have been interesting learning experiences for us, particularly in the late 90s, early 2000s. And it's interesting, there are still places in the world where they have a closure regulation, but no requirement for a financial assurance instrument. But the industry as a whole is recognizing that it can be a very significant financial responsibility. So in conclusion, what we've learned is some mining impacts cannot be eliminated. We often end up having to rely on models that predict future conditions. And unfortunately, that means we don't always know exactly what's going to happen, and we do our best early on using those kinds of predictions. We've also evolved the science and engineering of closure numerous times during the past 30 years. And there's been a greater emphasis on understanding the impacts of socioeconomic transition and the effects of closure on communities. So that brings us to this next topic, which we could do a whole nother webinar on, but I've got a few quick slides here. I want to talk about this. The reason why this has become so important is that probably beginning in about 2002, when the MMSD, Mining, Minerals, and Sustainable Development report came out, it was really the first time that a group of people, industry people, and a number of other groups got together, started thinking about how mining in general, but closure actually affects communities and people. So what actually is it? And basically it is a transition from a mining to a post-mining economic context. And all of us know that obviously people will lose jobs, direct jobs and indirect employment. But there are also things like economic development programs that may not continue or continue at the same rate. Community services that have been enhanced and or paid for by the mining company when it shuts down may need to look for other funding sources. That goes for health services and social investment programs as well. But if it's done correctly, we can still leave a positive legacy, but that requires early planning, early thinking, and also being able to look at the long term. Interestingly, this has become actually a very important aspect of the thinking of companies on mine closure. In 2020, the Mining Journal sent out a survey, and it was this was a review about planning for a successful closure. And about little over 400 respondents responded to a series of questions, a fairly significant survey. And when we broke them into these 5 categories, an interesting outcome, probably would not have been the same 10 years earlier, was that almost 40% of the respondents said that the most important KPI for closure was looking at the socioeconomic transitioning. Now, if you dig deeper into that data, you'll see that it varies somewhat by region, but this is the overall number, and it shows that people, the respondents, thought this was the most important aspect of closure going forward. Now, I'm not going to try to go through this whole slide, but basically what this is intended to illustrate, and you can find a copy of it in the World Bank Mine Closure Toolbox for Governments, and it's described in there, is this is trying to help us visualize all of the different responsibilities in mine closure and socioeconomic transitioning. Obviously, the mining companies and government have responsibilities. However, there are also other parties, communities, non-governmental organizations, possibly even other corporate parts of the corporate sector, non-mining parts. And then there's a number of shared responsibilities. One of the most important questions I think we're still struggling with is, where does the mining company's responsibility end? Are they responsible for are they fully responsible for the socioeconomic transitioning? Or are they only responsible for setting up the conditions for that to occur? And if so, what other parties are going to be involved in that process? One of the biggest challenges we have with socioeconomic transitioning is having the conversation with the stakeholders, communities. Having a conversation at the beginning of a mine life on closure is difficult because most people want to know whether or not they can get a job, how long the mine's going to be there, will they protect the environment, etc. So having a conversation about what things are going to look like when it's gone is difficult. Later on in the mine life cycle, when you're getting closer to closure, sadly, it becomes a sort of fear-based discussion, and there's a lot of concern about it. However, looking at this early helps evaluate opportunities for development and programs during operations that can actually mitigate a lot of the socioeconomic impacts further on. And as I said before, who is going to fund and execute the plans? It also gives you time to create sustainable partnerships with other entities, possibly government or pseudo-government organizations. There are a number of NGOs out there that get involved in this kind of work as well. So let's talk a few minutes about QP responsibilities with respect to closure. As all of you know, the language says, this is from NI 43-101, all disclosure be based on advice of a qualified person, which means somebody who has experience relevant to the subject matter of the mineral project and the technical report. Now, I know when we first started doing these, we often would have one person handling all the ESG, and sometimes we still do, depending on the project. However, closure has become a more significant component of a lot of these reports. And therefore, we tend to look for experienced closure people to QP those portions of technical reports. When we look at mine closure in the context of thinking as a QP, we recognize, again, it's a necessary part of the mine life cycle. Closure will happen. It's going to cost money, oftentimes significant money. And one of the other things is that it really should be managed as a capital project. If you're going to spend $100 million, say, on expanding a plant, you're going to handle that as a capital project. Why would you do it any different if you're going to spend $100 million on closure? And it is part of the public disclosure requirements, depending on which of the codes you're looking at. And obviously the two big ones we mostly deal with here are the Canadian NI 43-101, which requires disclosure of risks and costs, and more recently, the US SEC rules, the SK 1300. Now that's a new system, relatively similar to, but importantly, a bit different than Canada's NI 43-101. This is what the NI 43-101 discussion on environmental studies, permitting, and social, so basically the ESG components. And you will see here that any known environmental issues which could materially impact the project. One of the things we've seen recently is some jurisdictions considering laws that would prohibit projects that require perpetual care. In other words, if you have a long-term water management, water treatment, you could actually end up not being able to permit the mine in the first place. You'll notice there's also a reference to water management. Again, we got somebody with a microphone on. Anybody with known requirements, any water management, tailings monitoring, both in operations and post-closure, and discussion of mine closure, remediation and reclamation requirements and costs is also required. In the SK 1300, they get a little more specific, and this is a quick table with the 3 different levels of technical studies that are listed under SK 1300. And you'll notice that in the initial assessment, what we might call a PEA, you'll see that you just have to assume what the reclamation and mitigation plans would be. When you move to the technical report summary or PFS study, you actually have to have detailed reclamation plan determined. So by the time you get to PFS, the SK 1300 disclosure, you have to have a detailed plan. Now, you can still base that on reasonable assumptions, but when you look down here on the capital and operating costs, you're looking at a plus or minus 25% with a contingency of 15, not more than 15%. Feasibility studies, basically you have to have final plans and detailed assessments. So there are some very specific requirements. We'll come back to this whole issue of the accuracy of it in a few minutes. Okay, let's talk about costs now. So what do we use closure costs for? Well, we use them for technical studies like we just discussed, but we also use it for planning the project, budgeting and budget reconciliation, and annual financial reporting. There's requirements under all of the stock exchange rules, either operating under US GAAP or IFRS, to actually disclose your liabilities, including closure liabilities, in annual and possibly quarterly reports. And of course, there's permitting requirements in many jurisdictions, including financial assurance requirements. So, closure costs. The cost requirements, when you're looking at it from a permitting perspective, can vary significantly between jurisdictions. There are places in the world where there are no requirements whatsoever. There are places where you are supposed to document those, but you're not required to file a financial assurance instrument to guarantee that work will be done in the event of a default. These costs can be material, and they include key factors such as to think about when you're preparing it is, what are the receptors for impacts after closure? What point in the mine life cycle are you doing the cost estimate? And we'll get to that in a few minutes. What are the proximities to communities and water? And will you have water coming off the site? Those are the things that tend to really drive closure costs. Now, I didn't put this on any slides, but I will say it here. Rarely have I ever seen a closure cost that's been put into the public domain that actually represents the actual cost it will take to close. Now, there's reasons for that. A lot of times the regulations don't include things that will actually probably be done in the event that the mining company implements the closure plan on their own. And let's be honest, nobody's going to volunteer to put more money into a financial assurance estimate than is required by law. Okay, closure cost accuracy. Now, first of all, if you don't have a good plan, you're not going to have a very good estimate. And typically, the accuracy will vary quite a bit depending on the level of report that's being prepared. And one thing that's very important, I'm going to show you an example of this. We realized this in looking at SK 1300 reports recently. Closure costs may be less accurate than the overall cost that's reported in a technical report. That being particularly true when it comes to early phase projects. Now, if we look at AAC international cost estimate classes, which most of you are probably familiar with, the typical ones we deal with in most of our technical reporting are going to either be class 4 or class 5. And you can see there's a fairly broad range here. But these are the ones we typically end up with. When we start looking at feasibility studies, we start ending up somewhere between class 3 and class 4. But most technical reports are going to fall in 4 or 5. Now, let's talk about cost estimate types for a minute. There is more than one kind of cost estimate, and it's very important that we understand these when we start preparing one. Mine closure costs, you'll hear people say this, or a closure cost estimate. This is a very generic term that without context or clarification can be very confusing. And so what we typically do is we get our people to understand there's 3 primary types of cost estimates. There's ones done for financial assurance, one that are done to estimate the total cost of mine closure for a project, and then there are the financial reporting ones, or asset retirement obligation estimates. Financial assurance cost estimate, this is the one that you usually prepare for the government. It's an estimated cost for the responsible regulatory agency to perform all of the actions in an approved closure plan. Now, there are often restrictions based on requirements for government contracting. It usually includes the requirement to use third-party costs. There may be certain government contracting laws, and generally these are using current cost or a maximum near-term cost, not a cash flow model. In many countries, there is no requirement for financial assurance, and those that have it often don't include things like post-closure cost, which can be significant, and we'll talk about that later. Some only require financial assurance for a portion of the liability. Others allow the asset value itself to be offset as part of the financial assurance. Some of them allow in net present value calculations. And there are some, like in the US, where you're required to post 100% in hard securities. Then there's the life of mine cost estimate. Now, this is really the estimate that the operator uses to build into their financial models for the project. This is what they are going to do, what it will cost them to close the plan in the context of the current mine plan. And these are used for due diligence, feasibility, accrual allocation. These are almost always done on a cash flow basis, and it includes the entire mine site. So even if something's not going to be built for 20 or 30 years, it will still be included in a life of mine estimate. And then there's the asset retirement obligation. Now, this is what's used to report annually, or in some cases quarterly if there's a material change, what the current legal and constructive obligations are for the particular site. And it only includes those liabilities that exist in the current reporting period, either a year or quarter. And most of the time you're using a third-party cost, but under IFRS, you can also use some operator costs. There are a few other differences we'll talk about in a second. So what's the difference between these costs? Does it really matter? Well, these are a couple of slides here showing some differences. The red is the asset retirement obligation, and the purple is the financial assurance. This is based on a phased one. And what you see here is that the asset retirement obligations are slightly less. And the reason here is that each one of these purple bars is actually looking out 3 years ahead. And so the financial assurance in this year, in 2012 and 2013, also included 2014 and 2015. And as a consequence, but the disturbance only required, the amount that's in the bar in any given year. If we also look at the life of mine versus the asset retirement obligation, this shows what you would expect to see as a mine gets more mature. The asset retirement obligation is going to increase. And in theory, if there's not a change in the mine plan, other than inflationary cost changes, you're not going to see a big difference year on year for the life of mine cost estimate. Now you'll notice in this graph between 2015 and 2016, there was a jump in the cost. That was because they added another cell to the tailings impoundment. You'll also notice that between 2015 and 2017, there was no change in the life of mine cost, but in 2018 there was. And that was because they expanded a few facilities in the mine plan that they used for the 2018 life of mine cost estimate. So in summary, these are the 3 types of cost estimates: financial assurance, life of mine, and asset retirement obligation. And you'll see there are a few differences. The key ones I want to point out here is that typically financial assurance assumes third-party rates because governments don't have their own equipment and operators, whereas LOM and AROs usually use a combination of the two. Cost basis is usually current cash, but it can be in some jurisdictions cash flow. The life of mine and asset retirement obligations are always cash flow models. Salvage value is usually not allowed in financial assurance. It is specifically excluded from ARO calculations. And then there's another type, what we refer to as early closure. And the only real difference here is there may be some permit obligations if you close early that haven't been met through operations, and therefore will have to be picked up during the closure of the site. For example, if you've committed to place a certain amount of non-acid generating rock on top of your acid generating material, and you haven't completed that by the time you go to early closure, you may incur an additional cost to do that. So, closure costs. Let's talk about what all is included. First of all, they're the direct costs. Now, these are pretty straightforward. Most of us understand. You're doing things like generating the final landforms, putting covers on top of mine waste facilities, coming up with ways to manage your stormwater, decommissioning, demolishing your plant facilities and any other infrastructure, revegetating. Now, there may also be, depending on your site, you may also have water or solution management issues, getting rid of tailing supernatant, dealing with drain down from a heap leach pad, et cetera. There may be cleanup work if you've had contamination on site that wasn't already cleaned up. Sometimes this happens underneath various types of facilities that could have contaminated the subsurface, places like refineries, plants, truck shops, fueling areas. Those things all need to get considered. And then you also, oftentimes we include things like closure planning and various G&A costs and mobilization and demobilization. Now, there's also indirect costs. These include things like engineering and design, operations during closure, contract administration, project management, various types of corporate support, performance bonds. All of these things are in addition to the direct actions you're going to take. Basically, they're supportive of those things. And then the last one, of course, is the contingency, which we'll talk about in a minute. Now, indirect costs. Some jurisdictions actually provide recommended percentages for those to be used. And typically we see that for contractor overhead and profit, performance bonds, contract administration, and contingency. There are often included by others are percentages for things like mobilization, demob, engineering, permitting, camp costs. Now, honestly, in my opinion, I think to have a more accurate estimate, if you can reasonably calculate a cost, which you can do for those bottom four, you probably should be. And just throwing a percentage number on there, even if it's one that's approved by the government, may not be the right way to do it. Another point things that you might not realize if you haven't done a lot of construction work is when contractors give you a cost for mobilization and demobilization, they will often include a lot of cost in their mobilization fees. And the reason is they're basically trying to get some payment up front so they have cash in hand to move things onto site. So it may not simply be the cost of moving people and equipment to the site. There are other things that they will often include in those costs. Now, let's talk about contingency. I showed you this graph before, and one of the things to note at the bottom of this is what the AAC International recommends is that the contingency should be about 50% of the level of confidence for whatever your level of scope is. So that's a good rule of thumb for you to use. So about if you're dealing with a plus or minus 40% number, you should be looking at a contingency in the neighborhood of 20%. I've had a lot of clients who say, no, we don't need a contingency. I always argue with them, usually lose, but it is good practice, and it certainly is the recommendation of AACE. So where are our costs? This should not be a surprise to anybody who's worked on closure. You're dealing with your mine waste facilities and demolition, and then in this particular case, we had a significant number of things that were added into the indirects. Things like pits, not particularly big, but the things assigned for waste rock and tailings were more than half of the cost. And this is very typical. Obviously, if you have a heap leach pad, that would also take up a significant portion of the cost. Few comments on estimating costs. First of all, I said before, every site's different, every closure plan's different. That means you need to look at every closure cost differently and do them site by site. They're only as good as the plan they're based on. There are lots of different ways to do it. And remember, it's an estimate. It is not going to be perfect. The only way to know what it really costs to close a mine is to close it, add up all the invoices, and then you'll have the final number. So when we set up our closure costs, we need to understand what our plan says. We need to understand the objectives. We need to gather all the data. There's a lot of information needed to do it. We also need to understand how the mine will be built and how and when it will be closed. So are you going to build your waste rock dumps from the bottom up? Are you going to build them out from a particular area, expanding multiple lifts concurrently? What about the tailings impoundment? Is it going to be built in cells? Can you close them independently, or do you have to wait till the end? How often are you going to be updating it? There is more than one way to set up the model, and you need to really think through carefully all these things before you set up the model so that you can get the best use out of it. The information needed is pretty significant. A couple of key things I want to point out here: fluid management, water balance, and materials balance. Those are probably the biggest things that we struggle with when we go looking. Material balances, I would say that less than 5% of the projects we've worked at had a proper materials balance at the time we started working on the closure, and it's something we almost always have to create. Little bit about methods. There's a number of different methods: engineers' estimates, contractor bids, actual work that's been done on the site for which you have data. There's cost databases like means heavy construction, cost guide. There are standardized unit cost approaches. People have attempted to use first benchmarking. There are first principles methods as well. We'll talk about a couple of these. And there are a number of public domain tools that work. Here's just a few of them that are listed. Standardized unit cost. This is my personal least favorite because it's a unit cost for each facility or type of activity. For example, cost per hectare for tailings impoundment, cost per cubic meter for topsoil placement. Without understanding where this came from, you don't know how well it applies to your particular site. Not only that, the cost to move cover, for example, from a stockpile to one facility is not necessarily going to be the same as the other. As long as those averages work perfectly as weighted averages for your facility, that's great. But when they're built into a model that just has the standardized unit cost, you can almost guarantee you're not going to have an accurate estimate. These are usually based on an average or an average plus a standard deviation of some type. These don't consider site-specific conditions or facility-specific conditions or the closure plan that you have. Benchmarking. A lot of people want to use benchmarking. We did a very extensive study about 7 years ago, and we looked at 48 sites that use the same method for calculation. We evaluated, I think, 67 different parameters, desperately tried normalize labor because we were dealing with 5 continents, numerous countries. And what we found was the ranges of cost per hectare, because that's what this client wanted, were enormous. You can see that. And even the averages, the means didn't fit in the middle of the range. They were at different points. So I think there's questionable use for these other than just doing comparative analysis between sites. First principles is the way we prefer to do it. And oftentimes this is what an engineer's estimate is based on. Basically, you determine what work needs to be done, what quantity of work needs to be done, and what equipment and personnel you need to do it. And then you calculate the time to complete the work. So essentially what you're doing is you're calculating time. Once you have the time, calculating the cost is easy. It's just simply the time multiplied by the rates for equipment and labor. So as an example, if you have a stockpile of soil that you need to move to a tailings impoundment and place it, first you need a truck or trucks. Then you need something to load the truck. Then you need to calculate how long it's going to take you to get that from the stockpile to the placement location and back. Then you have to calculate in the time to dump it. You have costs for somebody to spread that and move it where you want it. And basically, a first principles calculation looks at all of these various factors, comes up with the amount of time it takes per unit for that particular facility to move the cover from point A to point B and spread it. And then it's a very simple calculation to calculate the cost of that. Few things to think about. It's an estimate. There will be rounding errors. There will be volume calculations and productivity calculations you rely on. These can all affect your costs. And really the level of accuracy depends on what you're trying to do with it. One cautionary note on models. This comes from George Box, a well-known 20th century British statistician. All models are wrong. The practical question is, how wrong do they have to be not to be useful? He's absolutely right. So I'm going to talk a minute because this is one of the key things where the cost estimates vary greatly, and that is calculating productivities. And I'm going to use dozers as an example. Most of you will recognize this graph here on the left. It's the dosing distance versus estimated production, hourly production from the Caterpillar Handbook. And you start with that and use that to, knowing your distance, you can come up with an uncorrected productivity. The next step would be to factor in grade corrections, then things like operator correction, material conditions, whether or not you're doing slot or side-by-side dosing, looking at job efficiency, and potentially altitude duration in higher altitude areas. And all of this information comes straight out of the CAT handbook. They may need to be adjusted based on site conditions, but at least you have a starting point that's a standard reference. And one of the key things here is, how do you actually calculate the average dosing distance? Well, if you look at knocking down a slope of a waste rock dump or a heap leach pad, you have to come up with an average distance. Now, what we often use is basically a centroid to centroid distance, which is about 2/3. When you do the calculations, it comes out to be about 2/3 from one end to the other of the average of the slopes that you're looking at. It's a little more complicated than that, but that's where we usually end up. Now let's talk for a minute about post-closure costs. As I said earlier, some places in the world don't require this as part of your calculation, but these can be significant. And almost always when they are, it's all about the water. It's about water you have to manage on site, process solutions, wastewater, etc. And the key thing there is, how long is it going to last? Will it be short-term, medium-term, long-term? Is it forever? And then how are you going to fund that? So there are a number of post-closure costs. I mean, monitoring and maintenance, I think we all know, and most regulations require that you include a certain amount of that in your cost calculations. But then there's also operating costs. If you have any kind of activity on the site that requires, somebody's got their microphone on again. Operating costs, if you have to manage water or treat water on the site, and that could go on for a period of time. And then if you're stuck for a long time, you could have sustaining capital costs, things like replacement of equipment or liners, repairs, rebuilds, that kind of thing. So this is scary. This is 3 sites we've worked on not too long ago. And these aren't even some of the biggest ones we've seen, but this gives you an idea of how significant the post-closure costs could end up being. And these are the post-closure, these were post-closure trust funds that we had to do calculations for. So you see that Site A had about a $200 million closure cost, but nearly $1.4 million in post-closure costs. And this was based, I think, on 260 years, I think. Now, obviously, the annual costs aren't this kind of number, but over 260 years in post-closure, they're going to spend another 1.4 billion. Here you see on Site B, the numbers were roughly similar, slightly more for the post-closure costs. Site C had a slightly smaller overall cost. This was a heap leach pad, if I remember correctly, but actually heap leach and tailings. But they had nearly 50 years of management of that site that were required, and you can see that that was more than twice the capital cost of closure. So as I said before, post-closure costs can be big and they need to be thought about, and we'll talk about discounting and NPVs in a minute. When you have big closure costs, and this is from a site we worked on recently, if you're going to have water treatment, water is going to be your biggest cost. The rest of it becomes really pretty insignificant. A major part of this water management cost is personnel, because you have to have people to run the plants. And if you're going to be doing that, every year the operating costs get expensive. If you're dealing with a remote site with a camp, you also have all of those costs added into it. And so these numbers can get quite big. Few closing comments. As a QP, or just doing a due diligence project, these are the things we typically look for. Does the closure plan comply with GIP, good international industry practice? Do the costs seem reasonable for the site? Now, obviously that requires a little experience, but if you have the right people on it, they can tell you, no, we're not going to close this for $10 million. This can be over $100 million. So if the number doesn't look reasonable, that's a red flag. Are the calculation methods used transparent and appropriate? Or do you just have a single number that says it's going to cost us $2 for every cubic yard of cover? Well, if that's the case, then you're going to have to start doing some calculations to make sure that that's a good number. Is inflation being addressed by inflating over an entire estimate over years and decades? We recently, I'm working on one now where we're doing an asset retirement obligation where they are still using the original costs from 2010 and they've been inflating them ever since then. So they've now have almost 15 years of just inflation factors onto the number, and they have not recalculated the cost since then. That's a red flag. Are they using equipment that's available and appropriate? Does the schedule seem reasonable? That's another one we often see. Somebody says, well, we're going to close this whole site in a year. Well, if you have a tailings impoundment, probably not. And so looking at that, and the longer you're out on the site closing it, the more money it costs because you have to have all of the associated indirect costs with that time. And then we often end up doing calculations, checking calculations. One of my big issues is there enough annotation? When I get a cost estimate that has lots of notes and I can see how the work's been done, it makes me a lot more comfortable than if I get one that's just a table with numbers and I have no way of knowing what's been done or how it's been done. So last of all is the basis of estimate. We always look for a basis of estimate memo. This kind of gets back to the last point about annotations. This tells us what methods were used, the basis for the rates, what the origin of those rates were, any assumptions that were made, and then puts the results out there and often compares them with previous calculations. Last comment I have is NPV versus current costs. One of the challenges with early phase closure cost estimates is they're far enough out in the future that when the numbers are discounted, no matter how significant they are, they have very little effect on the NPV and they appear to be immaterial. However, the further down the mine life cycle you go, the more important they become. We recently had a situation where we looked at 5 sites for a client. One of them had a 20-year mine life still. One had a 5-year mine life, 2 had 2-year mine lives, and 1 had a 1-year mine life. And they had not been reporting closure costs in their NPVs for a number of years. They hadn't been including them. When we took closure costs that we knew were not even adequate, we had 2 of the sites were now NPV negative. 1 was NPV neutral. 1 was barely positive, and then the long life one actually had a good NPV. So eventually your NPV will go negative as you approach closure if you continually update it every year. You shouldn't be surprised by it, but it does tell us that the shorter the mine life or the closer you are to the end of the mine life, the more important the closure costs are, even when you start doing discounting to come up with an NPV. Okay, this is a couple of minutes long. Questions? I don't see any in the chat.
Yeah, thank you so much, Jeff. I don't see any. Oh, here, I have one from Patrick. Material balance. Is this the accounting process for movement of materials around the mine during operation?
Patrick, hi, Patrick. No, actually, Patrick, what I'm referring to there is really closure material balance. You know, how much materials in your topsoil stockpiles. If you have need for drain rock, where is that and how much of that do you have available?
Okay.
Rip wrap, things like that.
Yeah, actually, we're going through that right now. We're closing a site and there's no cover material. So, yep.
Okay.
Thank you.
Looks like Hung Yu was drinking from the fire hose. So
Yeah, here we
that's
have
interesting. Yeah, I see Greg's. I've got the, as long as they're putting them in the chat, I'll see them. Greg, that's a great question. Should closure costs be added to each ton process? I know that there have actually been people who have looked at that, and there's certainly you could analyze that if you wanted to get your all-in costs. I believe there was a study done it's quite a few years ago. Colorado School of Mines PhD student was trying to actually come up with a closure factor that he could use to put into pit optimization studies. I can't remember where they landed with all that, but it was quite interesting. And yes, John, we can give you the URL links. We'll get those to you. Any other questions? I know it covered a lot of ground in a hurry.
Yeah, Jeff, you could put those links in your add to your slides, because we'll be posting the slides on our website.
Okay. I will do that. Some of them are already there, actually. Actually, most of them are already there. So it should be easy.
Looks like we have one last question from Garrett here. How important is this for the investment community?
Great question, Garrett. I'm actually going to be sitting on a panel in New York City next week at the SME meeting with investment communities and their lawyers, the investment community and their lawyers. It really depends. One of the things that the investment community has less concern about closure is because they typically are only looking at a payback period of, I don't know, maybe 5-10 years. Rarely do they expect to be invested in the mine through its actual end and closure. And so oftentimes it's not something that factors in unless it is going to result in either the project being actually stopped altogether or reduced in scale or profitability because of some issue that the government's worried about. Say they won't let you mine below the water table because of concerns with ART. And that would reduce the value of the asset that's currently mined. And we see more and more that they're being concerned about reputational issues. So they don't want the reputation of investing in projects that are detrimental to the environment or generate a lot of public opposition. Did that answer your question, Garrett? Okay. Legacy sites. This is a long question. I find that costs associated with characterizing tailings facilities and how best to integrate monitoring instrumentation have been significant. Any guidance from your experience in developing early cost estimates, percentage, or the time and effort to calculate based on area, depth of zone of interest? That's a very involved question, Ray. I'm not sure if you're referring to characterizing the potential for a tailings impoundment to seep water into the ground. Is that what you're referring to?
So in essence, Jeff, what I'm trying to get at is when a client comes and says, we've got a legacy site and we'd like some closure costs early on before we actually break the ground to do anything, what do you think it's going to be? Do you have any guidance or any experience in throwing out those costs to them, saying, look, you've got an area of 35 hectares. Let's go ahead and pop a piezometer in one of every, say, 100-meter spacing on the slopes or 300-meter spacing.
Well, it all depends on the data you've got, right? It's obviously if you've got good data, baseline information, then it makes it a lot easier. If you have almost nothing, and I'm sure you've seen the same thing, where you're going out there blind. You can if you really want an accurate cost, you've got some work to do. You need to understand groundwater conditions. Hopefully you at least understand how the tailings impoundment was constructed, so you have some sense of what protections are existing in the design. But then looking at it, and if you do have, once you understand the direction water is going to go, if it seeps into the ground from the tailings impoundment, then you can better decide where you need to put monitoring wells. Obviously, typical monitoring well installation, you've got to put some up gradient or cross gradient wells in, so you get a sense of what background conditions are. And then you have to figure out how many you need to see what would be downstream of you. Obviously, how much water is in the tailings impoundment, that's going to factor in. You'll need to do hydraulic property testing on the tailings impoundment to understand how quickly water is going to go through it. That'll help you design your cover. I mean, do you need a really low perm cover? Can you get by with a soil cover? Do you just need rock on top? All of those things. So I don't know if that helped. Any other questions?
Well, great. Many thanks to Jeff Harshley for his excellent presentation. Thank you so much, everyone, for attending the webinar. We do have several webinars coming up during the next few months. You'll get a notice of these webinars. The June webinar will be about aluminum and will be earlier in the day to accommodate time zone differences for our speaker. The webinars are generally scheduled for the third Friday of each month. All of our webinars are uploaded to our YouTube channel and will be accessed through the MMSA.net website. This video of the webinar will be on the website within a week. The MMSA webinars are supported by the MMSA Jacqueline Foundation. We will send you a notice when the video and slides are posted to the website. The webinar is now ended. Thank you very much.